Today we're going to be proving the arc of hyperbolic tangent of x is equal to half times the natural log of 1 plus x divided by 1 minus x, with x's range be between 1 and negative 1, represented by the absolute value of x being less than 1. For starters, we know the definition of the hyperbolic tangent of x to be equal to, by definition, e to the x minus e to the negative x divided by e to the x plus e to the negative x, which we're going to assume the outcome of this to be equal to the variable of a. Finding the variable of x, by definition, the arc of hyperbolic tangent of a. And now we're going to analyze this equation right here. E to the x minus e to the negative x divided by e to the x plus e to the negative x is equal to a. We're going to assume e to the x to be equal to n. Therefore, n minus 1 over n divided by n plus 1 over n will be equal to a. We can simplify both the numerator and denominator to get n squared minus 1 divided by n squared plus 1 is equal to the variable of a, multiplying n squared plus 1 on both sides to get n squared minus 1 is equal to a times parentheses n squared plus 1 to be equal to a n squared plus a. We can move a n squared to the left-hand side and negative 1 to the right-hand side to get n squared minus a n squared is equal to a plus 1. We can factor out n squared from this equation to get n squared parentheses 1 minus a is equal to a plus 1. And we can find n squared to be equal to divided 1 minus a on both sides to get a plus 1 divided by 1 minus a is equal to n squared, rewriting this to be 1 plus a divided by 1 minus a to be equal to n squared. Remember our previous assumption of assuming e to the x to be equal to the variable of n. We can apply e to the x back into the variable of n to be equal to e to the 2x power is equal to 1 plus a divided by 1 minus a. Hence, we can find 2x's value to be equal to the natural log of 1 plus a divided by 1 minus a. Divide 2 on both sides to get x is equal to half times the natural log of 1 plus a divided by 1 minus a. And remember our previous definition. We can find the variable of x through the arc of hyperbolic tangent of a. And that x is the exact same x that we have right here. So this will be equal to the arc of hyperbolic tangent of a, hence proving our formula. But before we do end this video, that is, we must argue the restriction of a. The restriction of a that will make this equation true. For starters, we know that 1 plus a divided by 1 minus a, the denominator can never be equal to 0, because that will make the fraction untrue. So from this, we know that negative a, it cannot be equal to negative 1, a cannot be equal to 1. And let us do that when 1 plus a divided by 1 minus a, when a is equal to negative 1. Well, this will be equal to 1 minus 1 divided by 1 minus parentheses negative 1, which will be equal to 0 divided by 2, which is equal to 0. But here we must bring up an important thing about e to the x power. E to the x power is always greater than 0. Why is that? Because there's no variable of x, inputs of x, that will make e to the x be equal to 0. That applies for any number as well, such as 2 to the x will never be equal to 0, 3 to the x will never be equal to 0, and so on. So e to the x will always be greater than 0. And why is it always greater than 0? The reason why is because any number to a power other than negative values, we're talking about only positive values, such as pi. Pi to the second power will be greater than 0. 2 to the second power will be greater than 0. 1.5537 to the power of 16 will be greater than 0. So e to the x will always be greater than 0. And e to the x will never be equal to 0. So when a is equal to negative 1, 1 plus a divided by 1 minus a will be equal to 0. So a cannot be equal to negative 1 either. Furthermore, what about values of a when it's greater than 1? Well, when it's greater than 1, let me rewrite our fraction. When a is greater than 1, such as a is equal to 2. This would be 1 plus 2 divided by 1 minus 2, which would be equal to negative 3. Let us do a is equal to 5. 1 plus 6 is divided by 1 minus 5 will be equal to 7 over negative 4. Notice how both of the outcomes are negative values. And remember our previous definition and proof that e to the x is always greater than 0. E to the x will never be less than 0. So these two outcomes, when a is a positive integer, will not make sense. So a cannot be greater than 0. This applies true for when a is less than negative 1. When a is less than negative 1, for 1 plus a divided by 1 minus a, such as a is equal to negative 2 and a is equal to negative 10, this will be 1 minus 2 divided by 1 minus parentheses negative 2, which will be equal to negative 1 over 3. This will be equal to 1 plus negative 10 divided by 1 minus negative 10, which will be equal to negative 9 over 11. Both of these outcomes, once again, are negative values. And remember, e to the x can never be less than 0. E to the x must always be greater than 0. So a cannot be less than 0 either. So if we go back to our previous defined proof, a has to be less than 1 and greater than negative 1. We can rewrite this to be the absolute value of a is less than 1, hence proving our equation that the arc of hyperbolic tangent of x is equal to half times the natural log of 1 plus x divided by 1 minus x, with x's range be between negative 1 and 1, or the absolute value of x is less than 1.